I think the big thing that's next for eBPF is I think actually what Thomas talked about at the eBPF summit. So eBPF originally began as this like Linux kernel technology as a way to bring innovation, flexibility, programming to the Linux kernel. Now we're seeing to expand to different areas too. So for example, Windows that we talked about, and now since it's all the AI hype right now, expanding to GPUs, DPUs, other things like that, and providing this as a consistent way to reprogramming operating systems level engineering. And if you think about like, why would you want to do that? And why is that actually important right now? And if you look like largely at the trends that we have, like we're starting to generate a lot of data. I think this is like a big trope now about, oh, there's data everywhere. Like we're consuming, we're producing it all the time. Like it's really important for AI models. But I think it actually is becoming a problem when you're actually just like looking at like the physics of the systems. We're producing more data than we can actually consume. So suddenly you can't be like observing your system, streaming that to the cloud, processing it there, and then going back to your system and doing things. Essentially bringing all the data to the intelligence isn't feasible anymore. We just literally don't physically have enough fiber optics like in the world to be able to do that. And so the question now is, can we actually, instead of bringing the data all the way to the intelligence in the cloud, centralized service like that, how can we bring the intelligence back out to the data so we can make intelligent decisions on the fly as we need them? And I think this is where eBPF is actually going to become a critical piece of computing going forwards, right? Because it's working at the operating system. It has a complete view of whatever's going on in your system, and it's able to reprogram the functionality there, right? Suddenly you're able to add functionality into the operating system and see the data that's coming in from the users and reprogram what's happening on the fly. I think this is going to be really powerful. And so, for example, one of the things that we're doing in Isovalent is you can do TLS parsing in eBPF, right? And then you can see what's in the package and make decisions based on that, right? Rather than having to export the data, doing traffic mirroring and doing those type of things. You can make decisions on the fly in real time and make it very granular about what you want to do. I think that's going to be really exciting because it's going to allow us to solve the problems rather than having to dig a lot more fiber optic cables, being able to shift around way more data. We can instead just reprogram exactly where the data is. I think this is why eBPF is going to be a very large and very powerful technology for really, I would say, a lot of infrastructure technology going forward.